Hello everybody, it's your boy back at it again with another maths video. Today we're going to be continuing our discussion on differentiation. I introduced you to the word in the previous video, differentiation. Differentiation. I introduced you to this word in the previous video and I said that differentiation is a way of calculating the gradient of any point when you have a curve. Like we discussed before, when you have a curve, the gradient of that curve changes, and whenever we're looking at the gradient of a curve, we are interested in the gradient at a particular point on that curve. So let's say we have a curve, a parabolic curve, y is equal to 2x squared. Just a simple parabolic curve. And let's say we want to know the gradient when x is equal to 2. We want to figure out the gradient of this parabola when x is equal to 2. Well, the normal thing that we would do is we would sketch the parabola on graph paper very accurately, and then we would very carefully draw a tangent at the point x is equal to 2, and the gradient of that tangent would be the gradient of that graph at x is equal to 2. But the purpose of differentiation is to take us away from all of that. We don't want to be drawing graphs and sketching tangents, because it's not very accurate, it's very time consuming, and it's complicated. For example, I can give you a curve that's very difficult to sketch. For example, maybe I want you to find the gradient at a point on the curve y is equal to 4x to the power 6 minus 5x plus 2, something like that. A curve that you can't really sketch. Even if you knew how to sketch it, it would be super time consuming, because your curve has to be extremely accurate for you to get an accurate answer. So differentiation gives us a way of actually calculating the gradient without having to draw or sketch anything. In this video, I just want to show you the notation that we use when we're differentiating. And then in the following videos, I'm actually going to go into the process of differentiating. So whenever we want to find the gradient of a curve at a particular point, we look at our function. This is the function y that is expressed in terms of x. So what we're going to do is we're going to take this function, and then we are going to come up with another function, and that function is known as the derivative. We're going to come up with another function, and that function is known as the derivative. That function that we come up with, it's going to be a function such that if we want to find the gradient at x is equal to 2, we're simply going to plug in the value of 2 inside that derivative, and we're going to spit out an answer, and that answer is going to be the gradient when x is equal to 2. Now that derivative, it is denoted by the notation dy dx. Okay, dy dx. This means the differential coefficient of y with respect to x, but no one is going to ask you to know that. Simply call it a derivative. It's just a cool name if you want to remember that name, the differential coefficient of y with respect to x, but in simple terms it's called the derivative. This is dy dx. If this function was p is equal to 2m squared, then the derivative would be dp dm. That would be the derivative. It would be dp dm instead of dy dx. If the function was z is equal to 2b squared plus 4b, you can see here that this is the function z in terms of b, so the derivative would be dz db, and so on and so forth. So that's the notation that we use for the derivative. And the derivative is going to be an expression that we come up with that is actually going to give us the gradient. So in this case, the derivative here would be 4b plus 4. And like I said, in this video, I'm not going to be showing you how to get the derivative. I'm just showing you the idea of the derivative. Here, the derivative would be 4m. That would be the derivative. And then here, the derivative would be 4x. So the idea is, if I have this function here, then I want to figure out what's going to be the derivative, what's going to be the gradient of this function when m is equal to 2, then I would simply go to the derivative, plug in my m is equal to 2, get 8, so 8 would be my gradient when m is equal to 2. Same applies here. I say, what is the gradient when b is equal to 4? I'd simply come to my derivative, plug in 4. 4 times 4 is 16. 16 plus 4 is 20. So my dz db would be 20. So my gradient when b is 4 would be equal to 20. Same applies here. The derivative is 4x. So what's the gradient when x is equal to 6? I would simply go to my derivative 4x, plug in 6, which gives me 24, so I know my gradient would be 24. So that is the idea of a derivative, and that's how it works. So we look at our function, and we come up with another expression. In this case, it's 4m. In this case, it's 4b plus 4. That expression is going to be an expression or a function. In this case, it's a function of b. Here it's a function of m. Here it's a function of x. And that function, it will allow us to get the gradient at different points by simply plugging in that point. So that's the idea of the derivative. In the next video, I'm going to be continuing on this idea of notation, because there is another notation that we need to know for the derivative of a function when we're dealing with differentiation. Anyways, we've come to the end of the video. If you enjoyed the video, please like the video, subscribe to the channel, press the notification button, and as usual, share the channel and leave a comment below. Thank you.